Hello, everyone. Welcome to week number 5. We are past the halfway point in the term. So let's see what we've got going on in Science 200. Let me get to the next slide. Okay, last week we learned all about scientific communication and the different forms and how you express your research to different groups and through different means. And so it's really important to find out who you are speaking to, whether it's writing or talking in a presentation or doing a YouTube video or whatever it is. You have to figure out your audience in order to tailor your presentation to that group. It includes definitions if you need to include definitions, extensive explanations if you need to do that. If not, you jump right into your research after you explain your question and your reasoning behind asking this question. So you have to figure out your audience and you have to figure out how to effectively present to that audience. So this week is all about biases in science and removing biases. So there are all different types of bias. We are human beings. We have a point of view. Boy, don't we know that on social media. Everybody's got an opinion about everything. Rarely based on any facts, but anyway, that is true. We all have biases from our experiences, from our beliefs, and all that sort of thing. And this includes scientists. So there are all kinds of biases in science. For example, the researcher herself or himself has bias. You have studied this topic for a long time and you understand what's going on, and when you design an experiment, you expect something to happen. You expect a certain result. Usually the greatest discoveries in science happen when something unexpected happens. When you find out something new, when there's a new piece of information that comes along, when you do your research. But you do expect things to happen in a certain way. And if they don't, then you need to figure out why. So that's important. Your subjects, clients, patients, whatever you want to call them in your scientific study, they have biases. So they know that you expect a certain outcome, a certain answer, and so you have to remove that if you possibly can. There are biases that come with who funds the study. So this is very important, and that's why you have to look at those financials when you look at a scientific journal article. Always look at the end and see who has sponsored this research, who has contributed money toward this research, because that will bring bias in. You know, if a conglomeration, if a huge biotech company like Monsanto is sponsoring your study on GMOs, they expect a certain outcome. And if you don't deliver it, they are not going to give you money. So anyway, there are biases and you have to take those out. This is one important reason that double-blind studies are so important. And I mentioned in my introduction that I was part of the Pfizer COVID vaccine clinical trials. Actually 3 different parts of that, and these were double-blind studies. So what does that mean? The researcher doesn't know which vaccine I've been given. This is only contained in the records and nobody can see it until the study is over with. And I didn't know which type of vaccine I got, whether it was a placebo, which actually is what happened in the first case, in the first vaccine that I was given, or is it the actual vaccine itself, the medication itself, the treatment itself? So that's a double-blind study where nobody knows what the treatment is, what the medicine is, whatever. And that eliminates a lot of bias. Okay, then this chapter also talks about p-values. P means probability. And you can think of this as confidence level. So if you see a p-value of 0.05, that means that 95% of the time, that's a percentage. So that's 5%, 0.05. So 95% of the time, you have confidence that this happened because of what you thought was going to happen. All right, that means 5% of the time, this could have happened just by chance. If you get a p-value of 0.01, that means 99% probability that this phenomenon actually did happen the way you thought, and there's a 1% chance that something else at random just happened. So p-values are very important, and they're stated in scientific work. You'll also learn about Gregor Mendel, who was an Austrian monk who did some genetics experiments on pea plants until he got a job as an administrator, and then he quit doing all of his science. I'm just saying. So I never wanted to move up in administration. I wanted to teach and I wanted to do research. So anyway, poor Gregor Mendel. But he grew thousands and thousands of pea plants and collected all the data from all the offspring that were produced. And he gave us many of the concepts that we still use today, like dominant and recessive traits. You all have heard that. You know about some of these. And he came up with that because of all the counting that he did. He came up with a simple hypothesis. He came up with good experimental design, and he collected and collected and collected data. So his experiments were elegant yet simple. You will also get some of this bias information, bias perspective, by looking at the Deepwater Horizon oil spill in 2010. And if you remember that, it was a horrific environmental issue that happened when the Deepwater Horizon oil rig basically blew up and spewed oil for many days into the Gulf of Mexico. And what you will see is that there was bias with the BP, British Petroleum. You know what BP stations are. So anyway, BP scientists were saying, well, there's only a certain amount of oil that's coming up out of the bottom of the ocean from this broken pipe. And scientists, federal government scientists said, no, that is not true. There is about 10 times as much oil coming out of there as you are saying. And finally, the government had to step in and say, all right, we're going to take a look at this because we don't think you're solving the problem fast enough, and we don't think you're taking this seriously enough, and you're just trying to cover over what is happening. So this is a really good start to this look at biases in science. You can be a scientist and have bias. You're also going to revise your rough draft, and you're going to come up with a hypothesis. A hypothesis is usually stated as an if-then statement, and it needs to be really specific. So you're going to say, well, what's the difference between that question that I asked in the beginning and this hypothesis? So you ask a really big question in the beginning that you research through looking at scientific sources. A hypothesis is more of a very specific question. So if you're looking into electric vehicles, that's your topic. And your question was, well, exactly how environmentally friendly is an electric vehicle? A hypothesis might look at the subject of how much pollution is caused by the production of one lithium battery for an electric vehicle. Okay, you could look at some issue like that. It's much more specific. It's something that you could design an experiment around instead of that gigantic topic that you came up with in the beginning. So realize that. That's what the hypothesis should look like. Make sure you use your rubric to guide your work, to do your work, because that is how I'm grading it. So realize that. No discussion board posts this week. You'll have those again next week in week 6. And the tip of the week is to use your feedback from me. I always give feedback, so please read it. Please improve your work by using that feedback, because now you know what I see in the work that you have shown me. And I also tell you how to fix it. So please do. That will help your work. In week 7, you have to have all the main body of your work for this project finished. and put into some speaker's notes, which we'll talk about soon. And then in week 8, you will put together a slideshow presentation about your topic. You're going to make a presentation to me, basically, with your slides to show all of the different sections that we have been covering up until this point. Okay? I hope that you have a wonderful week, and please let me know if you need anything. m.sigmon@snhu.edu. Talk to you soon.